Good morning. Not sure what happened to the stream overnight. There we go. Hi. We're going to do a quick 1 hour stream now before breakfast. Check on some experiments, make some plans for the day, do a few things. And then we will be back afterwards for pretty much the whole rest of the day afterwards working on dev. So first things first. Go check on experiments. Yeah, this is actually still running. I totally forgot about this one. I left a sweep going on Neural MMO. I don't know if it does anything. Oh. We got one good run. Interesting. I'll let this keep going then, because it is possible we find something in here that's just very difficult. And then I believe this is what we were going to go for here, is the breakout results. Yeah, okay, so we have here a good number of curves. You know, this is not really any better than before. I believe we got 19 seconds. 19 seconds before. Let me see if we can figure out why this sweep did not do as well. Breakout. Probably this one. Okay, so if we look at this one, right, this one is 50 mil. Heck, this is solved in like 17 seconds. So what happened that these two are so different? Okay, so we have the score. Both of these are good on the score. Total time steps. This one is over here. And this one is actually like quite a bit higher in total time steps. Oh, did I lock this thing to gigantic batch size? I think I might have locked this to gigantic batch by mistake. Let's go figure that out. Yeah, so this is the run. You have mini batch size here. And horizon. Batch size is auto. Ah. Yeah, that'll do it. Okay. So we'll see with this. Huh. We'll see if this makes a difference. And let this do a few runs just to make sure it actually is doing something. Environment/score. Hmm. Okay, so here we have logs. Interesting. For some reason, there's no score variable here at all. But I see the score variable. Oh, we have like some logs that don't have it. Hmm. I should do this ablation sooner rather than later because we have all sorts of annoying things happening from this. But it'll be fine for now. What we'll do for now is we'll just do We'll see if this runs. Cool. Okay, so the hope here is that we get something that is faster wall clock than our previous best, which should be doable. It should at least match this. 17-second solve. I don't know if we'll be able to get a 10-second solve, but a 15-second solve would be pretty darn cool. Like, I want to get something good enough that we can just put it in a GIF or whatever on X. Like the whole, like, this is solving an ENV live. All right. Put this over here. Backgammon and what? Oh, is that from today? Hey, Captain. 15 mils training with huge batch sizes. Cool. How much have you tested large batch sizes? Not very much at all yet. We're doing that stuff now. We did this. We have it pretty cleaned up. We did most of the small stuff on Saturday. We're working on getting nice stable sweep stuff. And aside from a few experiments here, I think we should do the packaging stuff. And like honestly with I think that the easiest thing to do is actually still to just ship source. I guess it will depend on how much slower Puffer is without the custom kernel. We'll have to see that. Oh yeah, also I wanted to do and I gotta pop the chat window out with this new setup. Yeah, so this is where we were at the end of the weekend. We had the C build, we had the torch build. We also go get our scythe on. Okay. I believe you have to call scythe and eyes on these, right? Oh. Okay, so you have C extensions, torch extensions, scythe on extensions. That is building. I did not call scythe and eyes. But that does build. And then there's like something about the torch limited API. Oh, I think we don't even care. I think we just get rid of this. We drop 3-8. What is the current Python version? Okay, so 3-9 is technically still alive. And then all I have to do now is figure out this CUDA extension thing. So there should be like a conditional compilation on this. Their setup file. This is CUDA extension C++ extension. This is what we wanted here. So they try to like auto find all the files, which we don't really care as much about, right? And then they compile both into one extension here, which is fine. This doesn't seem... Hang on. I don't think that this works. You can't compile CUDA, right? If you don't have CUDA dev. Okay, yeah, so their example is not correct. You just check NVCC. And do they compile with O3? Yeah, they do. I mean, they have a nice debugging setup here. I think I can take all of this, all their debug stuff. We can go like up here-ish. In fact, I can honestly like... Some of this can be extended even to more of the package, right? So I can do like... Yeah, like up to here maybe. Okay, so now we just need this one line. If CUDA home is none. You need to check that. so we actually get this. And how do they do NVCC? They provide the args either way. Do you recommend you're doing a PhD in reinforcement learning? What are your thoughts on academia? I'm one of the most negative people on academia at the moment, especially in RL. But I think generally, I only recommend doing a PhD to people who know they want to do a PhD. Um, for people who are on the fence about it, I'd strongly suggest like considering all the other things that you can do. Because it's 5 years of your life, and like the plus side is if you are in a good lab at a good university, you don't have funding bullshit to worry about, and your like advisor is supportive, then you get to work on like pretty much a very wide range of stuff for 5 years. The downside is you're doing so with next to no resources, uh, and almost like no funding to yourself. So like sometimes you're better off just doing it yourself as a company, um, or joining like a similar startup or whatever. And the really downside is the way that you have to write papers and how everything in RL, like how all work is formulated around the academic way of doing things. I'm not being particularly articulate right now. Let's just put it this way, right? I did neural MMO for 5 years. I had some like reasonable results, right? I put out some cool work. But then in the year since I've graduated, I've completely transformed the field. Like if you look at the stuff that we're doing now in PufferLib versus what was possible a year ago, it is like completely unthinkable to be able to do this type of stuff. And the way that I was able to do this was by breaking free of the academic mold. I had to do way more engineering than is typically accepted or appreciated in academia. Um, I mean, I really had to go deep on a ton of different things that like wouldn't really fit well into papers or like the type of work that academia is going to appreciate. But now, the results are here. So I guess the thing that I would say is like a lot of industry is allergic to doing real science, but then a lot of academia is allergic to doing real engineering. And neither of those things are good. Let me see if I can come up with something like more actionable for you. You're asking me first thing in the morning, and I'm not particularly articulate here. Okay, concretely, right? The like concretely, the thing that annoyed me, well, not even annoyed me, the thing that I thought was restrictive in academia, right? There is a very high premium placed on theoretical and mathematical improvements, even when they're like completely impractical or useless. Um, there's a very large premium placed on like cool sounding algorithms. Like if you have an algorithm that intuitively sounds cool that it could work like that, like you're going to get something really good published. If you come up with something that's really simple and beats the hell out of that like really complicated thing, you're not. Like the simplicity and the making things work and work very well is valued less than like a lot of clever sounding things that don't actually work. Um, there seems to be like an academic myopia around that, which is very difficult when you are actually trying to make things work. The lack of focus on engineering meant that things would just run like 1000x slower than they should in most of RL, which was the main limiting factor. That's the main thing that I fixed with PufferLib. It also prevented them, ironically, from even doing good science because they just couldn't run enough experiments to support any of their claims. And the crazy thing is that even with all of that, like, even when you show people, like, hey, you can run stuff 100 times faster, you can solve stuff with simple, like, methods or whatever, like, you get pushback even when you do that. So, I don't know. I found it, like, very limiting, and, like, you would think that it, like, academia would be a place where there's just all sorts of different approaches and perspectives and things, but it's really not. Like, it's really, like, I guess it's like the scientific method is, it becomes it kind of became the goal and not the means, if you will. Like, in my view, the way to do effective research, right? It's you do math, you do experiment heavy work when it's valuable, you do engineering when it's valuable, as is needed to solve your problem. But that's not really what it is. They're kind of stuck into a very specific set of methods. And as soon as they get bottlenecked by engineering, they're screwed, which is what happened in RL. There, that's a bit more articulate. It took a second because you got me within the first half hour of stream in the morning. But there you go. Cheers, huge fan of your channel. Thank you. Now, if you are, I don't know your background in RL. Maybe I should. I don't know if you're one of the end contributors or not yet. It's people have a million different names on the Discord and on the YouTube and whatever. But if you're looking to do some really cool RL stuff, you can kind of do things right now in Puffer. And it's a pretty special place now because, like, you can make things so fast that you can actually do, like, Google level experiments on one GPU now. And it doesn't take, like, a huge amount of code or infrastructure setup. We have things pretty darn simple. We've got, like, brand new people with zero RL experience who are now, in my view, as effective, if not more effective, than a lot of RL PhDs, just from having contributed and built stuff over the last few months. And it's a good mix of approaches as well, right? Like, we have science side stuff, we have algorithm side stuff, but we also have hard engineering, right? And we kind of use what is useful at any one time and bring them all together to make RL actually work. Just finished bachelor's and want to use the summer to get better at RL. I have some basic knowledge of the theory. What sort of projects would you recommend? Oh, then you're in a perfect spot. The thing that I always recommend to newcomers, and I have, like, a guide on my website for this, but just build a new environment that would be interesting for RL, something that's only going to be, a few hundred lines of code max, not a huge project, and then get RL to work on it. You get the whole process of building an environment, right? Running RL. You actually have to get to see the types of things that caused your env to break and not work. You get to see the common classes of errors. And you get like an end-to-end RL working on a new environment very, very fast out of it. So that's what I've had, like, most of these environments are from people doing that. Like, I built Neural MMO, MOBA, and Snake. The rest of these are from contributors. And there are actually like 6 more now at this point that aren't yet listed. So that's generally what I recommend to people who are new, is like, instead of just like studying, like, go do some RL, right? And generally it's like, it's fine to just like pick any existing game to implement and like make it fast and make work with RL. I think you're a little better off if you want to like think about what would be an interesting problem that would add something like that's different from these. Like, what would be like an interesting thing to look at with RL? Like, for instance, I got somebody doing Voids, which is this big multi-agent swarm type sim right now. We've got a driving simulator in construction. We've got somebody that's done like a physics shooter. Those are bigger projects. But like, I guess the example of this was like when I made Snake, right? This is kind of like a different and very interesting multi-agent environment, and this is only a couple hundred lines of code. Like, if you find things that would be interesting to look at with RL, or like are an interesting challenge in a specific way, that's usually great, because then you get the experience of also coming up with like a useful problem like that, implementing it, and getting RL to work on it. Also, just generally doing stuff in PufferLib, you will become a dramatically better engineer than most graduating PhD students very, very quickly. Like, most PhD students get through their whole PhDs touching like nothing but Python. It's pretty gross. This seems to work. So I think I just cleaned this up now, and I think we actually have a pretty reasonable package build. I think we spend a good chunk of today on this, and this actually is already in a decent enough spot. Yeah. I guess we have to fix Impulse Wars as well. But I can chat with Captain. I don't know if Captain, if you're still here, but I would like to figure out the build stuff at some point in the next few days, if not today. sure my experiment's still running. It is. Good. Kind of crazy that this thing is actually just running like 200 experiments in an hour and a half. Yeah, I think this will be the thing today, is get these sweeps working and get our packaging nice and clean. Hmm. It's pretty messy the way we do our install here. I mean, what's the alternative though? It's like it's this or CMake, right? Like, pick your poison. Yeah, at him in the Discord. I am gonna go for breakfast in a few around 10. I actually wouldn't mind so much if we had to do... I guess if we could compile... If we could compile Raylib and like Box2D with CMake, and then link it, GCC. Yeah, I would think here, like, we'd have to dynamically link, right? Okay, I'm gonna wait for what Captain says on that. I think that the assumption in the meantime is that we aren't going to do this. I think my intuition of not wanting to have this in the build process is correct, though. Because, like, just more garbage for people to deal with, right? Like, when I say, hey, come jam some C with us, and people are like, that sounds hard, and I say, well, do you know how to write if statements and for loops? It's like, yeah, okay, that's all we do. This is the code. It's really simple. That's fine. But then it's like, oh, also, here's all of CMake. It's annoying. It's way easier if it's one GCC command, which is what we have right now. Yeah. So I think at the most we use it to compile dependencies. Hey, Captain, how close to release are you? A week? 2? I don't know. It's as fast as I can do it, man. I'm trying to cap everything up together, though. Like, the goal is clean packaging, good baselines on all the M's, including yours, docs, sweeps, all that. Genuine question, how did you learn to do good engineering coming from an academic background? I know people said the only way to get good is to do it, but getting from 10K lines of code from a pet project to contributing to a library is definitely intimidating for me. Okay, so here's a few things. One, I just gave a shit about it. I really cared, like, trying to make my code better and better. Most people just didn't. Second of all, I needed to get good at it. Even just in the last year, I've gotten to be like 2 or 3x better at engineering than I was in the previous 10. Mind you, like, all the stuff I did before set me up for it. So, like, when I went from Python to C, it literally took me 3 weeks before I was perfectly happy programming everything in C. But yeah, that's kind of what that was about. But here's the thing, 10K lines of code, like, the core of Puffer is less than 10K lines of code. The core of Puffer is like 5K lines of code. And it solves things in RL that, like whole gigantic libraries just don't. And then we have like 30,000 lines of contributed environments. So like, you don't need a ton of code to have a ridiculously impactful project if you build stuff reasonably. Now, if you build stuff poorly, like if Fang were to try to make PufferLib, like if people in Fang were to like make an RL library like this, it wouldn't be as fast and it would be a bajillion lines of code, right? Like I've actually put a ton of effort into keeping it simple. But it's a very good way to build stuff in general. So I guess I've sort of specialized into getting pretty hard things done with like medium-sized projects. And also like contributing to a library, just start. Like literally just start. Like if you're interested in RL, come build an env and like go through the process of building an environment, integrating it with Puffer and seeing stuff. I gotta run for breakfast, so I will be back right after. But yeah.